Well, here we are. I brought out my big gun, the Knight Electronics Mini Lab 500. Built in 1988, and I've had it for a while, and rarely use it. But since I have a partner, I was able to get support on the right way to hook things up. We have this chip 8833. It's a Texas Instrument chip. It's good for a single motor, and it creates motor control from digital input, which is perfect for what we need to do. See some of my notes. But we worked yesterday, day before yesterday, and we just could not get this thing to fly. And I thought it over, saw some videos, and looked up some background on the chip and how it's used. Decided to get the mini lab out one more time, set it up, test it out. I tested all the functions, make sure that if I wanted to use it, I could. I tested it on some components that I have from my science fair electronics project lab, and it tested quite well. It's a good box, it's a good machine, it has a great meter, it's AC powered, and it has a huge power supply underneath the tray here, and it has a breadboard, it has lights, it has LEDs. It's just really, really good. So studied on how this stuff all works. I found there's a logic input. You can just toggle these switches, and it's just like you're a computer. You send a pulse over to that board and it'll react to the input just like the computer told it to do something. So all we wanted was to see output voltage. Now we're putting 10 volts in on this yellow wire, and these are switching, and when I toggle this, the switch, we should see 10 volts, and we weren't. We were seeing 0 for days. And then we ran this through this test, did everything possible, and you can see the little 4 silver dots underneath that IC chip, tiny little chip, 8 pins. Each one of those I tested with my meter back out to the source to make sure I didn't have a bad solder joint or the board was damaged in some way. Everything checked out, and nothing worked out of that board. It just wouldn't work. So I had another one. I took it out. I was nervous, so I had to solder this up. I had to solder that one up, and I soldered it, cleaned it, brought it over, turned everything on, and then I went down here to logic pin number 8, and you slide that forward, and what you wanted to see over there was 10 volts. .9, I'll take it. The other thing that we learned was when you shut this off, it stops. It has a very short coast. It stops pretty quickly. There's no carrying on. So I think we now have the pulse for the fan through this PC board. It's from Pololu or Pololu, and it uses a TI chip, and I'm just thrilled. Now, the other thing we talked about was It has both directions. I wasn't really sure about it, so I was told to push this one forward. And you heard that change in pitch. But what it did was it changed directions so fast you can't even see it. So let's turn this one off now. It's at rest. Now I'm going to put this one back on. Oops. Is something wrong? I thought it went in reverse. I thought it did. Oh, no. That's weird. How do I get reverse? Oh, it has to be. That has to be on? Oh, I know. You turn this one on first, then you turn this one on, and it goes the opposite direction. That's what it is. Okay, shut it off. Shut him off. Now you turn him back on, and he's going in the other direction. I get it. All right. Sorry about that confusion, but in any case, we have a pulse width modulation on the motor controller, or the microcontroller that we have. So what we'll be doing, in effect, is pulsing this very rapidly at a certain voltage, and it's not 5 volts. It's more like 3 or 4. But we'll be pulsing that signal, and the faster you pulse it, the faster the motor goes, and if you pulse it slower, the motor goes slower. So that's how we're going to get our speed control, so that we have the correct pulse, pump, I should say, airflow push for the puff we want at idle and carrying on. Okay, well, that's a lot of gibber, but the point is, we now have the board we had selected is the right board. We're on target. We now have it. We have a fan that works every time we tell it to work. We tell that pin to go high, the motor runs. Bingo. Now we're going to go back to my other bench, plug that in with all of the other Puff and Chuff stuff. What we're doing here was isolating the component inputs and outputs and measuring and checking everything going on, why and what, trying to figure out what we had done wrong here, and we didn't do anything wrong there. Amazing. I had like 5 of these, and I thought, how could I have a bad board? But everything we did was to the book, according to the manuals and everything else, and it didn't work. And then we know these guys are good. They don't make things that don't work. So build another board. Let's try it. And we did, and it worked. So either I built something, did something wrong, or it was a bad board. Don't know, but we got it. We have the fan. Oh, God, is that nice. And I can slow it down with my power up here, so you can get an idea. Oh, I'm just so happy. I know, it's a dumb little thing, a little fan. I've been running these little fans forever, but I've never been using pulse width modulation, which is sort of a pulsed wave, to run the fan. So I was a little unfamiliar when this chip didn't work. I didn't know. Now, I had built the pulse width modulation for the motor driver for the level 2, and I've got 2 engines with that, and it works great, but it requires 17 volts and stuff like that. So for the smoke fan, I wasn't sure if this was going to work the same or what. And when I get the board, is a tiny little board. The one I have for the motor driver is like a pack of Lucky Strikes or something. I'm like, wow, this little guy, I don't know, but it's a small motor, and all it needs to do is puff, puff, puff. So, pardon me. It's been a long haul. I cannot believe it. I cannot believe it. It's been so bad. All right. We're fixed. We're going to take this to the other bench tomorrow, Sunday, another train day, thank God. And we're going to just turn and burn and do the best we can. Oh, isn't that a nice sound? Maybe you can't hear it, but I know you can see. It's just a blur, and it stops, And it starts just so good. It's just so, all I do is I just touch this one little button. Boop. So neat. Okay, so I'm pushing 3 volts into this side, and then it's turning on 10 volts over there. Pretty amazing. Okay, gang, I'll post this. You can see it. You can, I don't know, think I'm crazy, but at any rate, I am on the moon. It's wonderful. We're going forward. Tomorrow is another day. Later.